Okay. As soon as the recording actually started, I assume that this is, let me mute myself here. Hello, 1, 2. Okay, so I muted myself. Okay, so as soon as recording started, I may assume that the lecture has also started. So I will start by introducing myself. So my name is Oles Dobosavich. I am actually an acting dean here at Faculty of Applied Sciences. The faculty is actually organizing the summer school. Previously, I was also a head of the machine learning lab, actually a research department that was responsible on the faculty on, it is still responsible on the faculty on doing different researches in the field of machine learning. Previously, before that, actually, I was a CTO in several YC and Techstars-based companies. Several of them were pretty successful. Several of them were unsuccessful. They are still, I would say, successful. I'm also have some background in data engineering, in actually playing with data. If you actually are familiar with Python, you may heard about such library called Celery. So I'm somehow involved in actually development plan of this library. And sometimes when I have time, I'm contributing to actually to do that development to this library. And I also have several publications on tier 1 conferences in computer vision. This is why actually all those stuff that I would be talking to you today about would be actually from perspective of computer vision and especially deep learning. And it would be somehow a continuation of those stuff that you actually learned together with Alexei in the early morning. So to actually start with, I want to talk to you a little bit about what is actually deep learning and is actually especially deep learning in computer vision and what is all this stuff about. And so we would ask first, I would ask you two simple questions. What's from your point of view is deep learning and what is actually computer vision nowadays? Any ideas? Yeah. So domain for which you need a lot of data and a lot of GPUs. And as a result, you would receive some paper or some result that would be published on tier conference and cited by a lot of people. Okay, what about computer vision? Okay, so I see that more or less you have some feeling what those topics are about, but in actually in real life it's pretty hard to define not the topics but the limits of those topics for the reasons that deep learning nowadays appears pretty a lot. There is an interesting citation from a book Understanding of Deep Learning that's actually the abstract start with the title is also partly a joke because no one really understands deep learning. So in general, the topic is very broad, and we would cover only some strategic direction where this topic currently are moving on, what are the priorities, what are the trends, and stuff like that. But to understand the topic very deeply, it's pretty hard for the reasons that it very often more not about formal science, but more about different approaches how you are learning these models and different tips and tricks. And I would show you that later on. From perspective of computer vision, that's also pretty hard, like to explain, like where are the limits of computer vision. I found like a formal definition on Wikipedia, and it says it's like interdisciplinary scientific fields that actually deals with how computers can gain high-level understanding from digital images or videos. I would like give you an explanation why this like definition is not like really good. For the reason, for example, that nowadays like computer vision is not so easy. And I would say like 20 years ago, computer vision like was about like recognition, like whether that's a cat or a dog, or about like edge detection, because like in early 80s, everyone was thinking that if they would understand like edge detection, then they would actually will understand like computer vision. There was like several motivation for that because they were doing like experiments on cats, and actually the experiment showed that actually the core yeah, so actually this like understanding of edges is like pretty critical. But what, for example, like this definition not includes nowadays. For example, one of the latest trends in computer vision is actually understanding of 3D data. And this is not only about understanding 3D data, but and like recognition, like whether that's like a pot or like whether that's like an apple or whether it's like another object. That's also about like relations between objects. That's also about like prediction future. For example, what would be shown on the next frame. You for sure saw some example of usage of Sora, like when they have like an internal image and they ask like to, based on that internal image, like generate you a future images, a future video, a pretty short shot that would show you like what would happen next. And this is also like a part like of computer vision. And those applications, they are somehow like are actually motivated by real life. And as soon as new motivation will appear, this topic will actually grow more widely and more like spreadly. Computer vision also is complicated for the reason that it starts creating like different issues that were not existing before computer vision exists. For example, I don't know like whether you saw, but Google with their Gemini, they released like actually an image generation engine. And where you actually, when you ask like this engine to generate you a photo of Nazi in 1945, it was generating you a black Nazi, for the reasons that they actually during training they introduced bias, and that was a historic, that bias that initially was expected to actually generate in same confidence white and black people were like actually generating like not realistic images at all, and that's actually led like to another bias, to historical bias. And at that point this like started to be a question of like not only a computer scientist, but also history people and other like from different like domains. So this is just several examples that shows that this like topic could be pretty broad, and you can actually find your place in this field. Okay, so I'm pretty sure you saw this image. I don't saw slides Alexei before, but if you are at least somehow familiar with the domain of actual artificial intelligence, or you at least tried like to um, pass like your first course in artificial intelligence, you probably saw this image. So what actually this image shows, this first like shows that first of all, it's like very important to actually to divide like artificial intelligence and machine learning. Anyone know like what's the difference between artificial intelligence and machine learning? Yes, that's pretty right. I would also to add here that actually artificial intelligence is, I would say, like LinkedIn term or Facebook term or Instagram term that is used like to define like any application of anything that would be related to anyhow like to machine learning or deep learning or anything. Like, so that's like overhyped word. That's pretty often like nowadays used just for marketing and to show that we are using like some algorithms that are not like written by if and else statement, but somehow learned like from other patterns. And that's like pretty general term. And I would say like it's even overhyped nowadays. But the important like topic that is like much more wider is actually a topic like of machine learning. And the reason why it's topic like is actually important because it's actually something that we will be talking about like today's like a little bit later on today. And under this topic, there is like three, I would say like categories, main categories. So let's talk a little bit about those three categories. But here I also want to mention that like I would probably assume that in a few minutes someone would raise hand and say there is much more categories. So actually about this much more categories, like we would be talking about later on today. And why those like, for example, topics like supervised learning are not like interested nowadays, and why those topics that lies in the middle between those categories are like more oftenly used nowadays, and they have like much more like actually interesting application. But let's first talk about like actually these three categories. So the first category, supervised learning. So the goal of this type of machine learning or category of machine learning is pretty simple. So you have like some inputs and some labels, and you want like to actually learn a model based on those examples. For mathematician, it can be defined like you have an examples of x values, y values, and you need to actually define like a function in any way, like either by actually approximating this function, either like by actually using like some clever tips and tricks. Yeah, and I would like importantly mention that this topic is pretty not as popular nowadays. And if you want to move like your way in machine learning, this is not actually a topic where I recommend you to start with. The next topic is much more important, and those topics that lie actually between like supervised learning and unsupervised learning are like even more important. So this topic is about like actually um, um, about case when you don't actually have labels of data, but you want to actually learn like some underlying structure or patterns in this data, and based on those patterns, like somehow like actually split this data. So the reason why this topic like is actually important and interesting for the reasons that actually first topic involves you to data annotation. And data annotation itself like is pretty expensive. And people nowadays like they don't want to pay money because like actually to make business you need to earn money and not to spend money. And so everyone like tries to find ways how it would be possible actually to find some patterns of data based on some like different approaches, either by not annotating as much data, either like by not annotating data at all. And those why like all these like interesting topics like are actually lying between like this supervised and unsupervised learning. The last topic, like the last category, like actually that is like usually machine learning is split into is actually reinforcement learning. So that was a very like popular topic several years ago when a lot of people were discussing about how actually either AlphaGo or other can actually overperform human in different games. But I would say the real life problems that doesn't have like as much application. It has like application like in robotics, like when you have a robot and it need to go like from point A to point B, or like in other domains. And usually to have like very nice reinforcement learning algorithms, you need either to apply before like unsupervised algorithms, either like supervised algorithms, detect like some features, extract those features, then feed them like within like reinforcement learning, and just then like all this stuff will start working. I would give you an example of a paper that we are actually were doing like with my colleague. We were actually designing like robot, or actually solving a task where like the robot need to go like 3 meters ahead under the degree of 30 under the 30 degrees. So you know like point where the robot is staying, and you know the point like where the robot need to go, but you don't know the environment at all. And you need to design like an algorithm that would allow you to go from point A to that point. It may sound like an easy task, but in real life, it's not an easy task. The reason for that is actually because those sensors on the robot, they are not like well designed, and very often they actually have a lot of noise and a lot of noisy data. And if you will reduce this task only to using like vision and depth camera, it becoming like very hard task for the reason that you don't know like whether like what was the floor, or whether there are like what are the configuration of the building, and if you would even limit like the time through which like the robot need to go from point A to point B, that would like be even more harder. And in this task, we actually use reinforcement learning, but the trick was not in reinforcement learning at all. The trick was only in approximating the degree on which robot turn on. And this approximation on a ton of data actually gave the real boost, not reinforcement learning, but this simple approximation how well like robot turn like from point A to point B, like what was the rotation degree of the robot. So reinforcement learning is all in all like is pretty interesting approach and can be used, but like that's often used on top of something and not like on top of raw data. There was a lot of expectation that it would be possible to do that, but nowadays like it doesn't seem like that's the best way to move forward. Here also like an important slide about like this current state of computer vision. So this is a talk like on ICCV. ICCV like is a tier 1 conference in computer vision, and I put it here like to understand like to explain you actually a state like where computer vision is nowadays. And there is like a Jitendra like actually tweet, and he wrote like, will vision people solve robotics? No, robotics will save vision. The reason for that is actually because like most problems are currently highly motivated by robots. I will give you another example. Assume that you have like you're driving like a Tesla and you're driving it like to some place. And that Tesla was probably trained like on a tons of data, like to actually to have an ability to go like from point A to point B, to detect like lines, to detect like those like actually signs that are like on the road. So it's trained like with a lot of data. The question is like, what would happen like if earthquake like would appear? The answer like is actually no one knows. But that's the main questions that are actually like everyone trying to address. Like whether we are possible like to train algorithms that would be robust to these edge cases. Okay, earthquake is something that can be simulated. So you can have like a pretty expensive like lab, like where like the earthquake is happening. You can put Tesla on top of that. You can collect a lot of data, do this training and so on. But assume something would happen that has never appeared before, like Black Swan, I don't know, like Fukushima, this issues that happened like actually on Fukushima. So what to act, like how Tesla would need to act in that situation. So the question is like whether we can create like some type of vision systems that would actually be robust like to that question. And this is like one of the important questions that nowadays are like actually raised like in computer vision. So this is why actually it's very often said that robotics is like really important driver like of actually of computer vision, and a lot of tasks are actually arising from there. Here is a slide from the same conference. It's actually ICCV 23rd year. So what I want to show here, I want to show here like numbers of papers like in different spheres. The reason why I want to show that to actually somehow motivate like I have a better version of that. It's pretty hard to read in that orientation. That's why like I rotated it for you. But the important like things here, I actually I mark them like with a red ellipse. So what you can see here. So first of all, you may see that a lot of stuff like are about 3D, like 3D from multiple view and sensors. Like later on, there is like 3D from a single image and shape and so on. But this 3D like is actually just a field in which this computer vision is applied. That's pretty obvious why in 3D, because like a lot of stuff in 2D is already solved and people are like moving like to 3D to actually solve this task. Others like important like tasks, questions that are here are like actually vision and languages. So this is like about like LLMs and so-called like VLMs that actually allows you to incorporate another modality like video or image into actually your large language model. This is actually something what ChatGPT could do nowadays. You can put like a photo into ChatGPT, ask to do some action, and it would like analyze your photo or some stuff like that. You can like, for example, like put a photo of a product and ask like what product is shown on the image, and pretty confidently, ChatGPT will answer you to that question. But the other important like topics that are like here on top are like something that related to different types of learning, and that's what we were discussing like nowadays. So you may see here that there are like transfer learning, self-supervised learning, semi-supervised learning, like meta learning, low shot learning, and other things. So those are like approaches that we would briefly discuss today. And I would show you some direction like to how what they are about, to actually, in case you would like want to go deeper like in computer vision or in application of computer vision. Those are topics like where you actually need to take a look into. So here is like our remember, like we have like machine learning, and there were just like supervised learning, unsupervised learning, and reinforcement learning. Here I made this diagram a little bit larger to actually show you that there is like a lot of stuff like in the middles that are like, as shown on a previous slide, are pretty, I would say, popular nowadays, and those that are approaches are talk a little bit nowadays. So to start with, I would go like, we are like supervised learning also, but let's go like one by one. So supervised learning. So as it was taught before, like supervised learning, it's a case like where you have inputs and you have outputs. The simplest problem like is classification, dog, not dog, hot dog, not hot dog. If you saw like Silicon Valley before. Yeah, so this is like a pretty simple task from when you have like a fixed number of classes, but that's becoming like not very useful nowadays. Any ideas why it's not like very useful nowadays? Assumes that you would have like even enough data and enough like GPUs to actually train this data. There is like even like more even more important reason, like not only about data labeling, but the reason is that actually that life is not so easy. You cannot have like only 1,000 classes like in real life. What usually when you're doing business, what's happening, the new classes appears. So for example, you were selling like shoes, jackets, and that's all. And then like your like CEO comes to you and say, yo, I saw that's like, I don't know, like hats are like pretty popular and I need like a third category hats. And like, what would that involve? It's actually will involve like actually you recreating like this model from scratch, like for all this like 3 new categories. If after a month it will come to you and ask like, I want 5th more category or 4th more category, that would also like you involve like 4 months of work or so. So this is why like those like approaches are like really becoming unpopular, except one actually thing. And this thing is about like actually segmentation. Can anyone like explain like why the segmentation is also classification? Yeah. So this segmentation itself, like even um, as like new fundamentals models appears, like SAM or like SAM-V2. So segmentation is also still a pretty actually complicated topic for the cases when you have like very special data. This is like medical domains, like or some genetic domains or some other stuff. Like so, where you have like very limit amount of data, and you cannot just generate like tons of data. And for that cases like this, like segmentation and the question like how to learn like on as low amount of data as possible is still like a pretty valid questions and can be actually uh, like pretty deeply dived. Okay, here is like actually an important quote. So Jan LeCun is actually head of Meta AI, and here, like on Twitter, his Twitter account and on his Facebook account, he actually mentioned like an important, like even like several years ago. So that actually, so that the supervised is not something that's like interested anymore. That you actually need to. It was like even like in 2019, even far before like nowadays that you need to start looking into actually such approaches as self-supervised learning, unsupervised learning, and other things. This is like where you need to focus. This is why we actually would talk a little bit about like unsupervised data and other things. You probably, if did Alexei mention with you like k-means? You probably heard like about such basic algorithms in unsupervised learning as k-means. This is why I would not be mentioning about them. I would be mentioning around like another like actually important like topic like in unsupervised learning. And here like this is a slide from Alexei Evros. So he is like a professor at Berkeley. And what he actually mentioned that the revolution will be not supervised. And what does he actually means is that we actually have actually like there is like an important like topic that actually is like self-supervised learning. So let's talk a little bit about it. What is this topic is about? So a formal definition is actually this is topic about creating a supervised task using unsupervised learning framework. Labels are derived from the input data, not external. And this may sound like a pretty complicated, like, or like not like very straightforward like definition. So I would give you an example. I had a nice example. So what that examples could be, so you have an image of cow and you actually have a label, this is a cow. So assume that we are not learning that this is a cow based on labels, this is a cow, but we would be start learning based on some side artifacts. Like for example, like that cow actually says moo. And that would actually allow us to, in the future, to actually define that cow is a cow. So it may sound like a pretty crazy example, but this is actually how it's actually working in real life. So what the goal is, so you have like a lot of labels. You actually are generating like some pseudo labels. Like for example, like for images, and you have like description for these images. Or like, for example, you have like an image and you have some meta text. Or like you have an image and you are artificially destroy this image. And based on that, you're actually learning like model. And then like you're extracting like features from this model, and that features are then used like to actually solve your task specific goal. So one of the most popular like approaches, like models that use nowadays, is CLIP, and I would show you one example how it can be actually used like later on. But like again, let's go like through the steps. Like so, the first steps like is actually you are generating like pseudo labels. So you have like an image, and you are generating like some pseudo labels that could actually somehow describe this image. Then like you actually solve this pre-task, and then you actually use this like features like or like some stuff that extracted like within this internal neural network to actually build you actually a model. I would give you an example like actually that's are pretty simple, and this like example is actually in text. So for example, like here is a model that's called BERT. This was for a long time like one of the best embeddings like for English language. So to actually convert your text like into embedding. What that allows you to extract like from text a vector, and that vector like could be then used like to actually pretty well we're describing this text, and that vector can be future used like to do the simple classification, spam or not spam, for example, or like whether this text is a spam or whether this text is not a spam. This is like just a simple application. The more complicated application was that those vectors are as good that they can be used, like, for example, for named entity recognition. So for each word, like it was like giving you a vector, and based on this vector, you can classify each word, like whether that was, I don't know, like allocation, or like that was not allocation, or whether that was like allocation, or there was not actually, or an organization, or like that was like again. And this model were actually, it may seem that like for such complicated vectors, like for vectors that are actually describing like this text, some very complicated model or like some very complicated idea can be used. But the idea that was used like actually was pretty obvious. And the idea was that they would mask like some parts of the text, and they would try to predict this word by those words that goes around like that word. So when you are speaking and you would just like when you would write like sentence, and you would just mark like one word with black, most probably the persons who you have never seen this text before very confidently can recognize this word. So that was actually the idea that was used like to actually incorporate, to actually train these embeddings. The same actually can be used like with images. What examples are used? For example, for unsupervised task, a jigsaw puzzle solution is oftenly used, like to build a pretty good models like on images. So to build an embedding that would actually be good to image, what is done? Actually, model the image is cut into pieces. Then it is asked, then are they randomly shuffled? And what is asked for a model to actually to put those objects in a proper place. The idea is also pretty simple, and this comes also from the logics that are behind the human understanding, like what we are seeing. So, or like how we are solving like these jigsaw puzzles. We are like solving these jigsaw puzzles very often by understanding that those objects, like the head, are on top of a human and not under the human, or like lie close to his hand. So there is like some internal like relations that are like possible, and this is why actually this is how like actually those embeddings are learned. And then based on these embeddings, like of those features that like actually network like was learned like internally, another models like can be made. For example, what type of model can be made on top of this jigsaw puzzle solution? Just a simple classifier, like whether like the object itself like is dog or not a dog. That would be pretty easy. You would need just a simple linear layer or linear logistic, like the simple logistic regression on top of that layer. That would actually just return you a confidence, like whether that's a dog or not a dog. And that can be just learned like in a few iterations. Another interesting topic is actually semi-supervised learning. So this is like an interesting topic for the reasons that it's a topic like when only part of labeled data are used, and it assumes that the rest part of the data is unlabeled at all, or we have like not enough labeled data, and and the rest of the data, we have a lot of data, but it's actually like fully unlabeled. So how this actually task semi-supervised learning works? So it's actually, there is like an approach that's called like student teacher. So if you know, like the teacher needs to teach students, that's actually a responsibility of teacher. So what's actually, how does it working? So the teacher is actually learning on this small amount of data, and then like actually based on those learned data, the pseudo labels are assigned like to the all unlabeled data set. And then the student is learned like on all unlabeled data set within the assumption that the labels may be incorrect. So this like those deep learning models are usually trained, as you may also potentially already saw, by simple gradient descent or like some other algorithms that are like have the same idea. So they by gradients. And you usually like when you have like supervised learning, you pretty hard are penalizing by wrong label. So you are saying, I know for sure I paid for that label. I know for sure that this should be car. In case of actually semi-supervised learning, you are penalizing, but like you're not penalizing as much. So you are saying, yeah, that could be, but if you're not sure, that's okay, and we would throw this label away. So this is actually like an idea of semi-supervised learning, and that's also like pretty oftenly used for data training. The interesting thing here is that it also can be we can also look on that like as on some type of regularization when you are actually like adding like and use this new unlabeled like pseudo labeled data to actually regularize your model and not like overfit like on this like 10 or 20 like of images that you are know pretty well. So this like also like can be considered as some type of regularization. So here is like actually this approach described. It's also important like to mention that this pair of words like teacher and student are often like not only used in cases like when you have like some labeled data and a lot of unlabeled data, and you are learning like based on this unlabeled data your student, and and teacher like is learned like on labeled data. This also can be actually combination can also appear in a so-called like teacher-student model. So the idea behind that is that when you have a lot of data, you actually want you probably would need like a large model. And you want like actually in production, like in real life usage, you somehow need to want to reduce like the size of a model. You even are ready like to have a little higher like metric, a little lower metrics, but like with having like a smaller model to having an ability to put it, for example, on your iPhone, or like to be just paying less money like for a GPUs like on a cloud. And what's oftenly like one of the techniques, there is like several techniques how that can be done. Like one is actually called like quantization, and it's pretty popular in large language models. If you actually run like at least like one large language model, or like if you've not run it easily, you can actually find a framework that's called Ollama, and would pretty easily from command line will allows you to run this large language model. But actually to reduce the size of large language model for the reasons that it's large, often like use quantization, and the idea of quantization is pretty simple. So we are actually dropping out like some actually some precision of the numbers that are like within our neural network. So for example, you don't like multiply by 1.5, you are multiplying by 1, because like 1 is pretty close to 1.5, and you expect that the result would be pretty similar. But like actually another approach to make the model like actually smaller is called like actually distillation. And the idea is that like first like you train like your model on this large model on a lot of data, and then you teach like your student model just to reproduce your results. So you are predicting like by this teacher model some results like on random images, and you ask model like to actually reproduce the same result, but the smaller model like student model is much more smaller, and you achieve that by actually doing by learning. Like one actually one interesting like applications that can be used in between of those two is actually using like or creating like multi-language embeddings. So assume that you have like actually embeddings like for an English language, and you want actually to have like as good embeddings like for Ukrainian language. What would you do? So the task itself like can be pretty complicated for the reason that this, for Ukrainian language, there is no as much data. It's pretty hard like to maybe mine your data in the specific field. For example, assume that you want an embeddings like for medical text. There could be a tons of medical text online for an English language, but there is like no data for Ukrainian language. So the idea is pretty simple how these embeddings are created. So just pairs of actual English language and translation to English language are used, and the model is learned like to have the same embeddings like on Ukrainian language as on English language. And this is like actually I explain you how multi-language clips are done or like something like that. Yeah, another interesting approach is actually weakly supervised learning. And this is like actually approach when you, and this is pretty often are missed like with semi-supervised learning. And I will try to explain you the difference. So in semi-supervised learning, assume that you have some annotators and you pay them some money to actually to annotate data, and those money ended. And you have a lot of not annotated data. In weakly supervised task, those annotators were just lazy. So they didn't want like to annotate bounding boxes. They just were putting you on your images. This is like a cat, and this is like a dog. And they were just too lazy to do much more for that amount of money. So the motivation behind that is pretty simple. So, and it comes like from this like actually diagram that actually from ICCV workshop in 2020. So it shows that like to annotate like whether there is like a motorbike and a person like on an image, you need like 1 second. To annotate like bounding boxes, you need 10 seconds. And to actually do pixel wise annotation, it would take you around like 78 seconds. And 78 seconds, like pretty a lot. And usually you are paying like your people based, or you either you have a limited amount of time per which like they are working for you, either like you are paying them per like amount of time that they're like doing this annotation. And this is why like the natural question arises, like whether we can do this segmentation based on just knowing like whether like a motorbike, this is like a motorbike and a person. And this is actually how like this weakly supervised actually working. So here is an example, again, like to show you the difference between like semi-supervised learning and weakly supervised learning. So in weakly supervised, you have just labels. This is like actually horse and person. And in semi-supervised, you can actually, part of data is actually labeled and part is not like labeled. So you don't know any information about that. And this is actually possible. So the idea of weakly supervised learning is actually pretty simple. So we train our model like to do this classification. whether this is like a person and a dog. And then like what you are doing, you are starting like actually analyzing this activation maps, like how your actually neural networks works. And there is like a lot of approach that they are called like CAMs or CAM++ or CAM-GRET that actually allows you from those like layers of neural networks extract like on which this on what this neural network was triggered. For example, like this neural network, like to identify this is a cat, potentially internally should start identifying like ears of the cat, or like, I don't know, like a face of the cat or some other stuff. And what's actually done, like actually this like layers of neural networks, like where it's actually triggering, like or showing high values are start like to be analyzed. And these layers are actually used like to do the segmentation, for example. Or like in case you have segmentation, you potentially can also approximate like bounding box based on this, like the segmentation, the bounding box of the object is just a rectangle around like this a map of a segmented map. So this is actually how like this weakly supervised like learning is working. And several more. So one more interesting approach is actually transfer learning. So this is like pretty popular technique. It's very popular if you want to start like your learning of data science from a Kaggle perspective. Does anyone know like what is Kaggle? Yeah, so Kaggle is a platform like where like the companies are like putting their tasks, you can compete, and who would like have the best model would actually earn like money. Usually people are not competing there for money. Usually people are like competing there like to receive like this label of grandmaster or like have several like medals and put it in your CV or somewhere else. Yeah. And usually like when you have like these Kaggle tasks, they are pretty tricky. And the reason for that is actually that initially they were like about like actually annotating like doing simple classification. So just like classify like on 1,000 like 10,000 images, like whether that's a cat or a dog. But then like what Kaggle actually realized is this is like pretty expensive to label data, and it would be pretty expensive to actually scale. And actually they realize that you can, and people are pretty interesting. And they are like having like a lot of nice ideas. So they start like giving like very low amount of data and asking like to learn something on this low amount of data on train, and on test they have like a huge more larger data set to actually test your like solution. And actually it's start like motivating like this fear that's called like transfer learning. And the idea of transfer learning is pretty simple. So when you're training like your model, you need like to start like from some base of your model. And usually the simplest idea is everything is better with normal distribution. So let's initialize like your base with your model, like with this like normal distribution, and that would be like a pretty good initial initialization. And it may sound like a pretty good idea, but in real life, it shows like a little different. And the idea that actually like was pretty highly motivated by Kaggle, and actually it's better not to start like with some random numbers, but actually start like with some large initial base that are learned on some large data set. For example, like CIFAR like 100 or some other data set where you already have like this task of classification. You initialize your model and you start like that, like from that model. The idea is pretty simple, and the reason for that is also pretty simple. Assume that you have like a model, like assume that you have a person that know how to actually determine like whether that's a cat or a dog. It's much more simpler to teach him like to distinguish cat, dog, or like, I don't know, like, or like parrot. Because like it's already so, that person already so like uses two examples, and you are like learning like on top of already existing knowledge rather like from scratch. So the idea of transfer learning is actually to learn like on top of existing knowledge, where it also can be pretty useful in cases like when you can generate a lot of synthetic data and you have like very low amount of actually real data. I would give you an example. Optical character recognition. It's pretty expensive task to annotate. Like it's pretty impossible like to actually to have like 10,000 of, if you are like just a random guy and you don't have like a top of annotators behind you, it's pretty expensive like to annotate like this data for the reason that it would involve several steps. The first, it would involve like detecting like the bounding box of the word or maybe even of the character. And then like you need to, after detecting this bounding box, you need also to mark like that bounding box with a specific character. And the task itself is sounds like a pretty hard, like because you would need like to collect, annotate a lot of data. And then on this top of, on this data, you need to actually train, just then you can train a model. But what's done like actually in real life, you can find a paper by Oxford group called Syntax. And this paper like shows that you can just generate pretty realistically looking text. And on top of that synthetic text, you can learn like your model that would perform like pretty similarly, pretty good compared like to the models that were not, that were trained like on real data or even better. And what is more interesting is that if on top of this model trained on synthetic data, you would even train a new model on real data, you would receive even better results. And this is like actually approach that nowadays like are used in different spheres. For example, like for robots navigation, you cannot have like a pretty good, you cannot have a footage of a robot from a lot of different places. There is like, I know this is the only one company that's doing that. They call it like Matterport. So they're like scanning like US buildings, like to show like to actually to sell them on some Zillow or other like marketplaces. But in general, like that's pretty hard, and that's like usually proprietary data. So you cannot just like you find this data. But there is like a lot of open source games. Like when your people are building like their environment, there is Unreal Engine that are pretty open source, and you pretty easily can build like your environment that you actually want to operate in. And what this allows you, that allows you to actually generate like a tons of synthetic data, train model on this synthetic data, and that actually train model on top of this like initial base like from synthetic data on some amount of real data. And this is like pretty clever approach that can be used like for actually for different stuff and pretty oftenly is used. Yeah. So about, so there's an example. Another like actually interesting application in transfer learning, or like actually a separate field that comes from transfer learning, is actually called like multitask learning. So the idea behind multitask learning is like also interesting. So assume that you want to train a model that would do image restoration. The simplest image restoration that you can do is like super resolution. So you have image and you want like to upscale it twice, like to actually to make it more like wider on all the dimension. And the task itself, like for image upscaling, is pretty similar to other like image restoration task. For example, task like that's called like dehazing or like raindrop removal or like some color restoration or some other task. And the idea behind that is that we would actually have like the joint model for all these tasks that would do actually embedding generation, and then like the same, it's called like encoder like for all this task, but the different decoder like for image restoration for different tasks. So idea is pretty simple, and again it's come like more like from math. The idea is that you can learn like a good vector representation of the image, and then based on that vector representation of the image, you can actually solve like different tasks. And and the idea is that by learning like this representation from different tasks that are pretty similar to each other, we can actually receive like a better quality. Yeah, about like reinforcement learning, like we already like talk a little bit. So the idea is that you are learning based on trials and errors. So you actually have a robot that's are like traveling like in some environment, and you have like a reward like for executing like a good action, and like actually penalty on executing a bad action. And you actually train based on like having like this like maximizing like actually this reward. And the last task like is actually also interesting. Like it's called like online learning. And this is becoming popular nowadays. And the reason for that is actually because data is changing a lot. And we may saw that pretty uh, and we may saw that pretty actually recently for the reason that actually, for example, the company that's called like Zillow, they were like actually having a startup like internally, and that startup like have like a pretty genius idea. The idea was that they can estimate the price of the house based on actually different factors. They were selling a lot of houses already, so they actually know this data per what real amount like the house was sold. Even if you will start like a machine learning course, that would be like usually one of your first homework to classify like whether that's what is the price of the house. And usually like everyone is showing this like possible to do. But in real life, what happened actually happened like a COVID happened. And then like the war in Ukraine happened. And the dynamic of the market like actually changed, and they did not predict that. So they were like learned like on the data just before COVID, and they started their businesses just before COVID. And they were expecting the same like when stuff like everything will go as good as like they will learn a lot of money. And what ended like actually they spent like around 8 billions on this company, and then they shut down like this company because they start like losing a lot of money, because like model like was learned like actually on the old data. And online learning is actually about like what are like the possibilities of a model to be trained like on live data. Maybe not like fully from scratch, but by incorporating like some amount of large new data with a mix like of all data, to not becoming model outdated and not to actually to make it still work like even on the new data. Yeah, so this is like actually all. We have like still around like 20 minutes, I assume. So I actually prepared like a notebook to actually show you an example of like of a model. And there is like also a homework. You're not obligated to do that. But like I'm as a teacher, like I usually like to prepare like homework for a task. Yeah. So there is like a model clip, and this is like a model from a company you probably know. That's like actually called like OpenAI. Where is this? You need to put also additional OpenAI. Wait a second. Yeah, and this is like a self-supervised model. And the idea behind that model is that actually, there should be a nice chart like somewhere here, yeah. That you are learning like which text the best describe images. So if you probably saw like newspapers or like any online text, like that's similar to the article, you usually know that there is like an image and there is like some text like is written behind the image that actually explaining like what is shown on the image. And the interesting thing is this actually information, like this description, can be used pretty extensively. And like one of the examples that I would give you is actually an example that was used like to creating like a data set of the faces. So what they were using, they were like crawling like in newspapers, and they were like looking for names. And if, for example, like there is like Obama shake hand to Biden, so they know that there is like two people are shown on the image, and this like one of them are potentially Obama, and the other like one is like potentially Biden. So it doesn't seem like original that there is like no information of such images, but actually you can try to actually use that information in a lot of pretty tricky way. So the idea of this model that is what they were actually maximizing. So they were maximizing like the confidence that that image would have like such type of description. And for that, they use like ton of data from Wikipedia. Wikipedia have a lot of like images and texts that are going like under the image. And this is like a lot of ton of data. And they just train this model. And it may sound like, okay, so they trained the model. And what about that? And what they realized, I think like they were originally playing that, but if you would have an image and you would have like several like texts, and those texts would look like a photo of a playing card dog, you would have a pretty good classifier by matching like the text with this text with the best this image with the best text that is similar to the description. So here is an example of code. So like what we are doing here. So we have like let me try to run it. So I have like I have it actually a lot of descriptions and a photo of a dog. It's called it's retriever, Labrador retriever. Give me a second. Wait a second. It's like downloading like the library itself. One second. It will take some time. But the idea is that if you, for example, want to introduce like another class, you can easily just like add like one more prompt. And I would say like this like was one of the first like model in era of prompt engineering. Like when you start like doing a lot of machine learning stuff with just like putting like prompts instead of like training like a huge models. But the idea is that by actually incorporating like this closeness of the image to the actually text, you can easily just create your classifier and you can easily extend by number of classes that you want. What's also interesting here is that it may seem that like it's like a silver bullet and it would solve like any task. But even in their paper, they are mentioning that actually that it would not work like in very specific domains. For example, yeah, you would have like satellite images of some very specific stuff, for example, like of rivers or of ocean or of land or of some other stuff, or like even like more specifically, like having mine on this land or not having mine on this land. So Clip would not help with that. It would can be a good maybe first steps, like first like initial ways, but you would probably need to actually do something even on top of that clip to actually to receive like some good result. You can just not use like this description and so on. Yeah, so you may see that here like is example. So we have like a lot of description. I would show you this photo. Let me show you. This is like a real Labrador. Yeah, so here is a dog. And you may see that by actually putting like a list of potential description of this text, you can actually find out which this text is about. Also interesting thing that this would not work like very good like with Ukrainian language, even if you would do train like this on translation. The reason for that is pretty simple. The models, translation model are biased. So they will not like translate you house in tons of different ways. So in English language, house like have like there is like only one word like to actually to explain like how like build, like we also can have like building, but in Ukrainian there is like also like much more like words that can actually like explain you house. And there is like even a technique that shows you how to break this model. It's called like synonym substitution, that allows you to actually break, like find like the best synonym that will not change the meaning, but actually the text like would rapidly would throw into different category. So all in all, like it's not like everything like as nice as possible. You can try like it's on your image. And the other model that I wanted to show you that also can be interesting for you, and you can actually do even more interesting task on that. So that's called like actually SAM. So there is like two models. This model was released like last year, and it's called like SAM stands SAMs for segment anything and not for Uncle Sam that are watching us. Yeah, so there is also like even a second version of SAM like called SAM v2. Yeah, and idea I would not like upload my image, but you can assume that it would work as good like with your image as with mine, with their image as with mine. So it's actually allows you to do very interesting stuff. It doesn't allows you to actually detect whether it's a frog or not, but it actually allows you, for example, to cut everything. It's called. Yeah, and it's segmented image you pretty precisely. Like, so you may see that like this frog is separated, like the lack of the frog is focus like separated, segmented separately. Also, the parts of the turtle is separate properly, and this is also nice. What interesting is that this like either like this model can be combined like together, like either with the model called like Clip or the model called like Ground in Dino. And what it would allow you to, it would allow you with two prompts, like actually the first one, find me as a rectangle of the tiger, and the second one actually uh, segment like start everything like in this bounding box. It will allow you to actually create a pretty simple actual segmenter of the stuff. And that's also pretty interesting for the reasons that it's again like an example. This is like supervised learning in some manner is like already outdated, and it can be it's already like sounds like a solved like task. Not for all tasks. Again, like from some medical domains, it's still pretty hard task, and actually over there like are like works better models that are like actually created from scratch. And very often like you even like need to create you to incorporate use some like classic algorithms to actually to detect stuff. And that doesn't mean also that's like the classic computer vision is like not used anywhere else, for the reason that like in the tasks like camera calibrations that are like actually in very huge need like for UAVs nowadays. The deep learning like is not like a silver bullet, and it's need to be done with like a simple, not very simple math, but with math. Yeah, and but in general, like a lot of tasks are nowadays like in deep learning are more shift like to this supervised and unsupervised like paradigm. I would share like these materials with you, and you can also like based on this SAM like write if you want write a simple classifier like of random images from Chernihiv village of houses, and actually write like a segmenter for this like objects if you want. If you don't want, you may not do that. I would not put you any grades on that about that, but if you would be interested, that would be a pretty easy task. So thank you for your time. We have like actually 6 more minutes, I assume, like for a question and answers. And if you have like them, I can answer for them. So usually the models that are like trained on synthetic data, they are not like really good in adapting like to real life situation. For the reason that synthetic data, it's still like synthetic data, it's like not real life data. And the models, they are like very tricky. They like to overfit, and they are like often like overfitting on something that you are not expecting. I had a case, like for example, with this weakly supervised approaches, like we were actually using like that, like in several like papers, like for medical data analysis and like other stuff. And like what we find out, like that when we actually were like there was this ImageNet model, like large ImageNet model, like that was classified like on a actually on all different classes. It has like a class like called fisherman, and it was not like actually triggering like on a fisherman like as a human. It was triggered like on a fish. So there was like class fish, like there was like a huge fish, and on classes like where like on a class like when it was like a fisherman, there was like a small fish. So it recognized like actually that the model was like pretty biased like to the small fishes, and it's automatically detect like it was much more easier for that model like to learn actually that when there is like a small fish, then this is like a fisherman rather than detecting like a person itself. And there is like a ton of cases, and usually um, on this like actually synthetic data, they are learning like the issue is that sometimes they are not learning like actually the real life situation. They are more like learning like some random artifacts that you actually don't know like how it would actually behave like in a future. And like with LLMs, like we have like a lot of these cases like of hallucination and other stuff that are actually my more so if you would like go to the list 3 and like ask it to generate it so like okay, if you would go to ChatGPT and ask it to generate like Zamok press tree, you would probably saw that it would like generate you a castle rather than like a usual lock, padlock. And this like for the reasons that like the data was not like balanced, and it probably was more like shifted like to the castles rather like in medieval castles rather than like to the padlocks. But that's like only in Ukraine. It's also important to mention. Kozatska Chayka is also a pretty complicated prompt for. I have like a case of the Lee. Like it's actually, if you're interested, while like people are, yeah, I have like this photo of it's like from other like lectures that I was giving like, yeah. It's tried hard. Actually, like on ChatGPT, they for some reason they somehow fixed that if you'll go like to raw DALL-E, it will not work. But on ChatGPT, they fixed that like somehow. I don't know like how. And the interesting thing is that they even fix it even better like nowadays for the reason that in winter, like it was like not like Kozatska Chayka, it was like more like some Russian ship like in that like period of time. So it was not like looking like historically like correct. It was more looking like as some Russian ship like with of that period of time with Norwegian like elements. It depends on task, and it depends. the short answer. But like in actually, yeah, in most case scenario, like transfer learning like show much more better approach than semi-supervised learning. And that's is like more proved by Kaggle than by me. So this like as I told you, this is like a pretty popular technique over there, and like most of Kaggle grandmaster will tell you that you need to start like from like the best initial ways are like ImageNet, and this is like the best encoders that you can start with, and on top of that you can actually do a lot of different stuff. Even like sometimes like a medical domain, uh, I would not like be here like very confident, but very often in medical domain, like it makes sense like to start like from general model to classify like is this ImageNet models to classify dogs versus cat versus something else, rather than from starting like on some classification from initial ways of some classification model that would like be like cancer or like in the lungs or existing having cancer or not having cancer. So like the general ImageNet model is like pretty good like initial base for anything, usually in most case scenarios. Yeah. This depends on the amount of data that you have, but like I think like training on fine tuning on unlabeled data still makes sense. Like for the reasons that you're like adding like some regularization on top of that. And if it's not like not performing like well on like there is like a technique, like I would suggest that the best technique here is like actually active learning. So active learning like is technique like when you are actually like labeling some amount of data, training model on that, then like selecting like from unlabeled data the data where the model is not the most confidence. Assume that you have classes and like it predicts like for both of the classes like confidence 50-50. That means that you need like initially to label these cases and like do several later doing like some by some. This is like the simplest example of active learning, but by iterating like several examples in such a way through the several iteration of labeling will help you to achieve the best results actually. So I would say like not semi-supervised learning, but like actually active learning like would help like you to work with this unlabeled data. Yeah. Liquid neural networks, those like are neural networks like to simulate Navier-Stokes equation or like to no, I don't know. I know the person who is like an expert in it. Like, no, he's not an expert for that. I know this is like a field like is pretty actively developing, and there is like a lot of good results there. But like, I would not like name you the paper or something like that. I can try to find you like an advisor, but like that's pretty hard for me. Even if my background like is in differential equations, but that doesn't mean that like differential equations and deep learning, that's not something where I actually pretty dive into. Again, for the reason that deep learning is pretty wide. And that's and also about like deep learning, what I want to say that if you will actually study like different like fields like from different perspective, you pretty often realize that actually a lot of ideas are like reused like from natural language processing into computer vision, from computer vision into natural language processing, from natural language processing into audio processing. Like for example, like the model wave to VAC is actually is fully uh, based on two papers. It's called like VQVIE, vector quantization, and the other paper is actually this like Roberta. So this is like just a mixture of two papers that they reuse like the ideas from computer vision, from natural language processing, and receive a paper in audio processing. Pretty tricky, but still like the ideas like are used. People from audio all the time saying that the people from computer vision are like saying this all the ideas in audio are taken from computer vision. Yeah. uh, to actually, so SAM will not provide you the labels of the data, and grounding Dino will allow you to actually founding like the bounding box of the data. So yeah, so what you can use like in this, like you can use grounding Dino by asking like to detect like windows. It will return you the bounding boxes of the image of the windows, and then you would ask like SAM to actually to segment you that part of the image, or you will just like segment the whole image, and you would find like the masks that would fall into this bounding box, and that would allows you to find a pretty precise segmentation of window. Yeah. Yes. 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 So you can like actually use that. There is like a notebook like in the internet that you can. Um, I can answer like for the next question while typing. Yeah, yeah. Yeah, it's improved. Yeah, rapidly. Yep. Siegel. So this again, like, so this like just an example. We actually, I was working like on a like my PhD student like was working like on a currently like on collecting like this data set like for synonyms, and like actually checking like whether like the large language model like can like pretty well detected like the synonyms, and actually in specific like for Ukrainian language. So you can actually find like this paper, and there is like a data set for that like actually, and they have like even some evaluation over there. He has even some evaluation over there. So there is like much more example rather than this. And in general, like the quality is pretty bad. Like it's like something may still be improved, but in general, like it's not as good. Yeah, so here is like an example, like when they are like detecting bench, and then like they are like actually using like grounding Dino to actually segment this bench, and then like even like repaint this bench like with stable diffusion into like another like object. So what they did, they actually use grounding Dino to detect bench, then use SAM like to actually to segment like the largest object over there, and then like actually they used the stable diffusion to actually to replace like this object with another object, or replace like doc like with, or just keep the bench, I think, like, and replace doc or something like that. So you may play with that, like the keywords are grounding Dino, SAM, and actually and stable diffusion. Also worth to mention that like not all examples can work, and the reason for that is actually that the deep learning itself like is pretty highly involving like sphere, and sometimes like that's happening, that's like something that was working like 3 months ago is not working at all. But that's like a computer science in the state, like what's is like what is what is actually how it's like currently nowadays, and yeah, so no one's cares anymore like about backward compatibility. Yeah. Yeah, Alexei put it me like tomorrow today in the morning. So I would probably suggest some projects. I was not prepared like for that. So I would like put several projects like today, like in this chat. I was not even yet ready like to do that. So there was like a request, like because he told that like a lot of people are interested like in computer vision and deep learning, and that's why like actually he asked me to be involved. So I was actually thinking like about like two topics. Like the first topic like would be around actually this that's called like um, visual disambiguity. So when you have like actually, let me give you an example. So you have like this padlock and lock and castle. There are like two same words like in an image, and like the project would be like to actually create like a model that would allow you to actually identify like whether it's an image of padlock or like an image of the castle. That was like one project. And the other project I was thinking like about like was about like document intelligence, and document intelligence specifically like for Ukrainian language. So there is like a huge field like called like document AI that actually allows you to actually to train like a model, like to actually to identify like some surnames or first name like in a document, for example, in a passports like or so. So I need to actually shape these two projects like in my mind, but I would probably will try to give you today like as late as tomorrow in the morning like this project. I would also need to give you data. For the reasons this will not be as easy like to actually to use it. Yeah. Yeah, so it, yeah, yeah. No, no, I was more saying that the generated synthetic data could introduce like some biases, and in critical situation, you also don't know these biases. So, so so this is like a huge domain called responsible AI to fixing like such biases and detecting like on early stages. You have Denis. So Denis over there like is actually pretty actively doing like research in that domain, and you can talk with him like whether that's an easy task or not. But in actually, my answer would be this like easy task for the reasons that very often it lies like not only from on not only like in perspective of computer science, but also in perspective of I would say like some ethics and ethical questions, like and like what was ethical like several years ago nowadays could not be ethical at all, and like and vice versa. Okay, so no questions. Thank you. So have a break. I would ask Alexei to share like with this two like folder, and having a nice rest of the your summer school.